Tiga. Assalamualaikum warahmatullahi wabarakatuh. Hello, doctor, and good afternoon. My name is Daniel Trihendarto Tandra with my partner.
Muhammad Hilmi Pasha Pranoto Setio, and today we're going to do the exercise 4.
So, what is exercise 4, Hilmi?
Exercise 4 is about we do like calculation of the polynomials, right, Daniel?
Yes.
And
It is an association.
yes. Okay, so do you want to explain the question first?
Sure. So basically, we're doing a polynomial. Let's say, for example, a single variable polynomial, where we have the 5 power of 2 minus 2 power of 0.
Yeah.
No, power of 1. Sorry.
Yeah.
And then plus 7. So in here we have a term
the
which,
example,
yes, which is the 5
5x,
power and then
5x,
minus 2 and 7, and then we differentiate those by a coefficient and exponent.
Right, so the coefficient is in the term there's 5x
Power of 2.
power of 2, right? So the coefficient is 5 and the exponent is the square, like the power. Yeah.
Yes. So it works for the minus 2x and then
Yes.
also the 7.
Yes.
Here in this table of UML, we can see those that are private and public.
Yep.
Would you like to explain a bit?
Yep. So there in the polynomial class we have the private class of polynomial, input and evaluate. These three we don't want the input to be changed, so like we make it to a private. And also wait, no, this is it like, yeah, oh sorry, this is the public one. This is the public, so the polynomial input and evaluate are going to be changed a lot, so that's why we make it public. And in the term we want the coefficient and exponent to not be changed, so it's private, and the rest of this is going to public because
Yes.
it's going to be changed and that, yes. And it's the relation of this is the
0 to many.
yeah.
It's only a singular.
Yeah. All right, shall we go to the code, or is there any more?
Sure, maybe a bit.
Yeah.
So in here we have our coefficient and exponent, and then it will work as an attribute.
Yep.
Then the term as a constructor.
Yep.
Next is the set, which is inside here is the coefficient and
Coefficient
exponent.
and exponent.
Then later on we have the get for both the coefficient and exponent.
Yep.
And later on the formula
The
to make
formula,
the what it equals to. Let's say
Yes.
if the x is 2, then if the coefficient is 5 and the exponent is 2, then it will generate the number of 20.
Yeah. It will just sum up the
Yes.
whole term.
And
no,
then-
not the whole term, but the
Yes, for that
only
single term,
so
right?
for the single term, yes.
And then we're doing a class for both input and evaluate for the
So yeah,
class
for
polynomial.
the polynomial.
Let us
So,
begin, Hill.
Let's go.
Alright.
Let's go.
My bad. That page. Okay.
Okay. So first, what are we going to do?
Our name.
Of course. So let's start with the name first.
Good afternoon, doctor.
We are at N28, third floor. Daniel Trihendarto.
Oh my god, you know.
What's the last name?
Tandra. Oh my god.
Same. Okay, so this will be filled later. Okay. So the first thing that we're going to add is
Doesn't matter first.
the custom. Yeah. Okay.
Okay. Last
Alright.
term given. Okay. Let us start, Hilmi.
Let's go.
So here, for the constructor is given, right? So
Yes.
now we implement other methods, which
Yep.
is the set, the get,
Mhm.
and then the evaluate.
Yep.
So let us start by getting a set first.
Mm-hmm.
So here, inside the bracket, yes,
Inside of the
enter.
curly bracket.
Yeah, curly bracket.
Mm-hmm.
So C stands for coefficient and E stands for exponent.
True.
So we declare it first. So
Okay.
coef, like COEF,
Oh. coef
equals to C,
equals to C,
and then do the same with exp
exp
equals to E.
equals to E.
Yes.
Okay.
Next, we do the exponent first.
Okay.
So inside the exponent, so it's just a get.
Mhm.
So it's not set. So what do you expect to get from this function is to return what you want.
Absolutely.
So we put return exp exponent,
exp. Okay.
and we do the same for coefficient.
All right. So just return coef. Is it?
Yes.
Okay. And then this is the different part, the evaluate, right?
Yes. So it's the same. We're going to return an integer, I
Mhm.
would say.
Mm-hmm.
Now, so let's do the calculation.
Mm-hmm.
5x power 2. So let's say the 5 is coefficient, so we put coefficient,
Coefficient.
the coef,
Yep.
and then we times
Times it.
with a formula with power.
Power.
Okay,
This.
inside the x,
The x. Right.
and then the exponent
X
of
for
exp.
exp. Just okay.
Okay, and then we curly bracket, and we're done.
We're done. Okay.
Switch.
Let's go. Kena pulpen. Pulpennya meledak ke laundry. Gak sengaja ke laundry. Kocak ya.
Ah.
Okay, so for the next part, we're going to tackle the polynomial class because without that, we cannot input it and get the degree and calculate it. So we're just going to go. Okay, so first thing first, we're going to define the polynomial from the class. So like just make a polynomial class.
Okay, polynomial
Polynomial.
class, poly.
Yes, nomial.
Yes.
So two double dots and polynomial. The we're going to make it a function. So brackets, and then the curly brackets. Yeah.
Okay.
Okay, that's going to be the construction.
Mm.
Right. Okay, so the next thing, we're going to make an input, right? Right. Okay, so for the input, we're going to make the function as void.
Void.
No, and then the next thing is you write the class name as
Okay.
polynomial. And then double dot.
Input.
Input, yes.
Okay.
Input as the function. So brackets and then curly brackets. Inside of the curly brackets,
Inside the curly bracket.
we're going to ask the user what to input, right? So cout. So like enter a polynomial.
Enter a polynomial.
Yeah.
Polynomial.
Yes. And then an L. And line, yes.
And line.
And then we want to make the input, right? So we have to declare it first, right? So because it's going to be an integer, so integer.
Integer.
We can call it whatever. So I will say num
Integer
as
num.
number, yeah. And then don't forget the semicolon, okay. And then after that, we're going to ask the user to how much the term is, how much the user wants the term, how long does the user want the term to be.
Okay, so we
So
put
like-
how long does the user wants to be?
You can say, as the question stated, how many terms.
How many terms?
How many terms? Okay, and then after that, do the as the and then you can semicolon, and then after that you're going to cin the num. Okay, all right. So after that, because it's already inputted, and then we want that to be like put it into a vector, into an array or vector. So first we're going to declare a vector here.
Yes.
Sorry, in the
In here first, right? Include the vector.
include the vector first,
Include a vector.
because it's going to be with a C.
I forgot.
Okay, because it's going to be easier if we use vector, because it's going to be like in an array?
Agree.
Okay, so
Because the question asks us to do it in a at the list of terms
Right,
of polynomial.
right. So
So it's a list of terms.
Yeah, exactly. So because we have the vector already included, we also going to also have to input the vector inside the polynomial class.
Inside the polynomial class.
In the
inside
private.
the private.
Yeah. So we can do like vector,
Vector
and then the sharp arrow, sharp,
for term, right?
yeah, for term.
Term.
We can, and then the name of the vector, terms. We can just name it whatever, so we can call it terms, yeah. Okay, and then we're going to go back to the input, okay, and then here what we're going to do is we want to create a for loop that
For loop.
will include the polynomial and like the terms into a loop into the vectors inside
Okay.
the vector. Okay, so what we're going to do is we're going to initiate a for loop. Inside of the for loop, we initialize I, so integer I.
Equals to 0.
Yep, equal to 0. You're right. Oh, sorry, equals to 1.
1.
Yeah,
Okay.
equals 1. And then semicolon to divide it, and then I is less than or equal to the num. And then I plus plus, because we want to make the for loop to be less than or equals to what we entered, like the terms, right? Okay. So inside of the for loop, you can do like the curly bracket,
Inside the for loop, okay. Curly bracket.
and then enter. And then here we're going to ask the user to input the polynomial and also the exponent. So we can initialize the coefficient and exponent. Coefficient.
It could
and
be
then
both. It could be both because
Yeah.
it's the same.
Yeah. And then after that, we're just going to ask the user, so cout, enter term, number, term, yes, pagar, number, and then beside it, arrow, I, because we want to like tell the user what's the term,
Yeah.
okay. And then we want to tell the user to input the coefficient and also the exponent, right? So you just write the coefficient and exponent.
Okay.
Yeah.
So it's more like this.
Yeah.
Coef
Coef and
and
X.
xp.
And just put an arrow to indicate where the user can input it. Okay. After that, you're just going to semicolon and then go to down. We're going to see in the coefficient and the exponent.
Ah, I see.
Yeah. Coef, and then arrow more to exponent. Okay. So, and then after that, we're going to what's this called? We're going to like call the function
Of the term, yes.
Yeah. Call it
So term.
the class term, and then t. Inside of that, we will include the coefficient,
Coefficient
coef,
and exponent.
and also exponent. Yes.
Okay.
Okay. So semicolon. We're done, and then the last one, because we're inputting the numbers, inputting the coefficient and exponent, we're inputting it into the vector. We're going to. Are you okay? Oh my God.
Yeah, all good.
Okay, so because we're going to input the coefficient and exponent into the vector that we just made, we're going to use the already made function for for vector, which is pushback. So we can use terms.
So we use
Terms as in the vector name, right? So
Yeah.
terms dot push underscore back.
Scroll back.
Inside of it is t, because here from the term t. Yeah. Okay. So and then we're done for the input.
All right.
Okay. So you want me to explain the evaluate first, and then you can just largest term and degree.
Sure.
Okay. So next function that
Wait,
we're
just so
going
you
to-
know, doctor, we use the formula in here. we follow this.
Yes, we're following the functions.
Yes.
Yeah. Okay.
So we already made the constructor,
Yes.
and then the input, and then
Yes.
the evaluate, then
Yes.
find the largest term,
Yep.
then the degree.
And the degree, yes. Okay. So the next here.
Hmm?
Oh, not there. After the curly brackets.
Oh, it's here, the curly bracket. Oh yeah,
Yeah.
yeah. Forgot.
Okay. The next function is going to be evaluate. So what this function is going to do is that where each term that has been calculated in the term class is going to be then added into one another. So this is what we're going to make. This is what the function is made to do. So the first thing we want to do is obviously state the class. So integer,
Mm.
integer because we want to return type to integer. Is it raining? I hope not.
Hope not too.
And then the class name polynomial. And then double dot, yes, evaluate. Inside of the bracket of the evaluate, we want to make it an integer x because the already made function is also integer x, and we're going to make it constant. Yep. And then inside of the curly bracket, we want to curly bracket. Okay. And then we want to initialize the largest. Sorry. No. Sorry. We initialize the sum. So integer sum. We declare it as 0 because it's the starter. And then we're going to do for loop. And then inside it's going to be a constant. And then term, as in the vector. And we're going to pass by reference here by using the ampersand.
Pass by reference.
The 7, yes. T. And then a dot, double dot, the first name, term.
Terms.
Yeah. Inside of the for loop, we're going to sum all of the terms, right? So it will make sense if we do sum plus equals to t dot evaluate x inside of the bracket x. Yes. Okay. So and then in outside of the for loop, we're going to just return the sum.
Turn
That's
sum.
it. Yep. That's going to be it for the evaluate and also input.
All right.
Okay. So you want to change?
Sure. Let's go. Be careful behind this.
Oh, you're right. Oh my God, it's right behind me.
Yep. So next, what we're about to do is that we have
Mhm.
2 extra functions,
2 more. Yes.
which a class I mean,
Oh, yeah,
which
class.
is sorry,
Yes. Okay.
finding the largest term
Mm-hmm.
and then the degree
Yes.
of it. So let's say for you have out of all the terms like 7, 5, and then 4, and then even if it's equal to 5x
Yep.
power of 2
Mm-hmm.
and such, so we find the biggest, the largest one.
Yes, because
So-
we want to get the degree of it.
Of course.
Yep.
So now let us start by making our class first. Okay.
Yeah.
So we use term
Term,
polynomial
polynomial,
with the double dot,
double dot,
and then we do largest term
largest
Yes. term,
term. Okay.
and then outside the bracket
Uh-huh.
we put it as constant. because,
Constant.
Yeah, we want it to
You want
change.
to be
Okay.
constant? Okay.
Okay. Then we set the barrier first for the
Right.
first one.
Right.
So we do term largest.
Mm-hmm.
Okay.
Mm-hmm.
Equals
Mm-hmm.
to term
Mm-hmm.
inside a pagar bracket, a fence bracket,
Oh, what?
a fence bracket. No, terms.
Oh, terms. Okay, sorry.
terms.
Terms.
And use
Oh,
a
this one.
Yeah, no, the rectangle one.
Oh, this one.
Yes,
Okay.
0.
Oh, so
It's
it indicates the first. Okay.
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 Now to find this, since we're using a vector, we want to set it one by one, right?
Right.
So we use a for loop in this case.
Or.
Okay, we put inside cons. No.
Oh no. Okay.
Cons. We use the term.
Mhm.
Okay, and then we pass by reference for t.
Okay.
and
Like
then
the
we use
first one?
double dot for terms.
Okay.
So in this case, it's used as a we indicate in the vector like
Mhm.
to pick for which one that we choose.
Yeah.
So
We
let's say
compare, right?
yes. So
Yeah.
let's say we have 4s, and then so it indicates one by one first.
Right.
So inside, what does it do?
Yeah.
It finds.
Yeah.
Okay. So let's say we do a conditional
Sure.
statement. If
If
okay, t
t
dot
t dot
exponent,
okay
okay, then we put the bracket.
mm-hmm.
It's larger.
larger than
Largest.
Oh.
We put its largest because we don't have large.
oh so
bigger.
like yes
No. The
bracket
okay,
largest
largest because we
Okay.
have the variable largest.
yeah
Exponent.
exponent
Yes. So in this case, we have t dot exponent and largest
largest dot
exponent.
exponent yeah
So we summon those two functions, I would say,
mm-hmm.
and we put the bracket also.
What?
Bracket.
curly bracket
Curly bracket. Yes.
Okay.
Curly bracket. Then we indicate that
Mhm.
the largest
Mhm.
itself is t.
okay so largest
Largest equals
equals
t.
T.
Why we just use largest? Because we already mentioned it here above.
Right.
Term largest.
right
Okay.
so
So
outside the for loop
outside the for loop, we return what we want, which is the largest.
okay oh sorry
Return largest.
there we go
There we go. Next, the degree.
okay
Let's say your power is 2, that means your degree is 2.
Yeah.
That's basically it.
right
Okay, so we put out our
return type
we put our public class not description. How was it? Class. We mention it first. Okay. We summon the class first. So
Yeah.
since we're getting an integer, so
Uh-huh.
the integer, and then the polynomial,
mm-hmm.
double dot,
double dot
the name of our class, degree.
degree
Yes, we put a bracket. Outside the bracket, we put constant,
constant
and then we put a curly bracket.
curly bracket
Inside, we return what we want,
mm-hmm.
and it's gonna be largest
largest
term.
okay
Yes. The curly with the bracket,
brackets
and then the exponent itself.
oh so
Dot exponent.
dot exponent
Yes.
okay
Because degree is basically the exponent that we're looking for, the largest
right
one.
right
Because let's say a single variable polynomial has like x power of 2 and then x power of 3, x power of 4, or
Right.
even the other way around.
right
It will summon the 4.
Yeah.
Okay. So
for sure
now we do the integer main.
yep the last thing we do
Let's
okay
switch.
that's good okay so we are heading into an end the next one should be pretty easy so the next one we're going to do an integer main right
Okay.
okay so
Wait.
bawah.
Test. Okay.
Ah,
That's
thank
it.
God. Okay, so below again. Okay, so there's already something that in the integer main. We're just
Mhm.
going to add some things more. So
Okay.
the first thing that we're going to do is that we're going to make an object of the class.
An object. Okay. So polynomial, right?
Yeah, polynomial.
Okay.
Wait, no, not an object. What's it called?
An object, I think
Object,
so.
right?
An object.
Okay. So whatever we're going to call it, we're going to call it p.
P.
P, yeah. And then
Yes.
after that we're going to create a polynomial object, right? So and then we're going to enter the details of the polynomial, right? So C out,
Hmm.
just do like enter details for the polynomial.
Enter details for the polynomial.
Yeah, okay. And then after that you're going to end L, end line,
Okay.
end line, and then here we're going to summon the input method. So P as the name, and then dot input,
Hmm.
and then brackets. Don't forget because it's a function. Semicolon, and then after that, what we're going to do is that after we get the input, we get the coefficient, the exponent, blah blah blah. We're going to get the degree.
Yes.
We want to make the degree, right? So what we're going to do is C out, the degree, we're going to tell the user that the
Okay.
degree, right? So
Yes.
the degree
The degree
of the polynomial is.
of the polynomial is.
Oh, I didn't know this.
Me neither.
Polynomial is, and then we're just going to right beside it. We're going to summon the function p the dot degree.
P dot degree.
Yeah, summon the function of degree with the p. Yeah, okay. Semicolon, don't forget, or just end line.
Do inline first. Okay.
And then first, and then semicolon. Okay. So after that, this is not this the lines and also the end line and polynomial value will not be changed, and then also the loop is not going to be changed because it's going to print out the x that we're going to use, and then we're just going to straight go for the oh no, sorry, the loop is going to be modified
Okay.
because it will not like calculate anything, right?
Okay.
So what we want to do is that we want the loop, the x, to calculate our coefficient and also our exponent, right? So inside of the loop,
Inside the loop.
beside the
So here,
yeah, beside the t
TT
Uh-huh.
here.
we're just going to summon the function of evaluate. So p dot evaluate.
P dot evaluate.
Yeah, and then brackets
Oh, brackets.
first, and then we can do end line after that.
Okay.
Uh,
Does it have to be value here? inside?
Oh, we have to pass the value of x.
Value of x. Okay.
Okay, because we're going to calculate the x with the coefficient and blah blah blah. Okay, and then we have come to an end. We're just going to do some like what you call it, like error cost.
Okay.
Like,
Okay.
So if you
Just to
want
make our code prettier.
yeah, just if the user decided to this is enough, we're just going to enter and close the program.
Yes.
So just see out,
Okay.
tell the user to
So in here,
after that,
after this.
see out.
Okay.
Yeah,
So we're just being graceful.
being great. Yeah, true. See out,
See out.
arrows, and then tell the user that if they enter the enter key, it
Mhm.
will just end the program.
So
Press enter to exit.
so press
Enter.
the
Yeah.
button. Enter.
Yeah.
To
Enter.
exit
Okay.
the code. Wait, gimana?
The
The code.
Okay.
Okay.
After that, we're just going to semicolon, and then after that, we're just going to cin dot ignore.
Oh, okay. Cin dot ignore.
Because all the white what you call input, and then cin dot get.
Could we wrote it like from get to ignore first? I don't ever know.
Yeah, I think we can do it. Yeah.
Yeah, I think we should test that later on.
Yeah. Okay. So that's it.
That's it.
I think that's it.
All right.
Okay.
So what's our input?
Okay.
Let's say?
So the soal.
the
What's
soal.
the soal?
This is the soal. Yes.
This is the soal.
The
Okay.
question.
The question. Okay. So the
Let's run it
first-
first.
Let's run it.
Control. Okay. How many terms?
Let's go with the one term first. One,
Okay, 1,
and then the coefficient will be 3
3,
space
space
2.
2.
The exponent is 2.
So I run.
Yep. So we're just going to check first, and it's correct. 0, 3, 12, 27, 48, 75.
Should I press the button enter to exit the code?
Yes.
To twist.
Tutuksut.
Okay, let's edit that one first. Okay,
Okay.
Control save, Is there another one that we can run?
Yep. There is going to be.
Wait.
What happened?
I don't know.
Okay.
No problem.
Okay. So then we can test it with two terms.
Two terms. Okay,
Two
so
terms.
two,
Yes. And then the first coefficient exponent is 1,
one.
and then exponent is 1.
Okay.
And then the next one will be minus 10,
Minus 10.
and the coefficient will be 0. Okay, so we're going to check 10, 9, 8, 7, 6, 5. Okay,
Alhamdulillah.
Alhamdulillah. And then the last one that we're going to check is. Oh. What happened there?
No. I have to do it twice.
Okay, the next one we're going to check if the four term can.
In here, our maximum is 5, right?
No, the maximum is whatever we want.
Really? I think we put it here, right?
The max is that is the x, the maximum x. So it will calculate 6 x's,
Hmm?
but it will not limit our terms.
Really?
Yeah.
Interesting.
Yeah.
Oh yes,
Yeah.
the only the output that. Okay,
Yes,
okay.
exactly. So
Let's
four
say
terms.
we put 10 terms.
Okay,
No,
that's
50.
ambitious. That's ambitious.
Okay, 4.
4. The first one is minus 5
That's 5.
and 2,
2,
1
1,
and 3,
3,
1
1,
and 0,
0,
minus 7
minus 7,
and 1.
1.
Got it? Okay. We're going to check first. 1 minus is it 10, minus 25, minus 38, minus 43, minus 34.
Absolute cinema.
Let's go.
I think just for the sake of the daughter, we're going to, make it like neat.
Okay.
Okay. Thank you very much.
Thank you very much.
So we
Nice,
finished
nice.
our. So what date is today?
The 19th.
Oh yeah. Oh shoot. 19, 12,
2024. It's going to be New Year too soon, guys.
Yay! Time
17:39.
17:30. No, it's from. So
Oh,
I think it's 17.
17. Yeah. 17. 00 to 17:39.
17:39.
The duration is 39 minutes.
39 minutes.
And we're going to include the video link later.
Yes. All right.
Okay.
Thank you
That's
very
it.
much, doctor.
Thank you
That
very
would be
much,
it
Doctor.
for us.
Yep.
Let's say together.
Yep.
Wassalamualaikum warahmatullahi wabarakatuh.